Hi, Ghislaine. How are you? Test my camera real quick. Hi, everybody. We'll start in a couple minutes. I just want to make sure I have my camera angle the right way. We'll work on the lab today. Just a reminder, we don't have live meeting tomorrow. So if you still have question on the lab, please watch the video. Okay, so let's see here. Let me check my camera real quick. Okay, I can move it. All right. Okay, so we are going to go ahead and get started. I'm going to go ahead and get started with the first exercise. So if you want to do this exercise, you can get out your Arduino. You will need a cardboard box. And I think I chose too big of a box, but if you want to adapt it to battery, you can. You will need some wires, and you don't really need a breadboard if you have the male to female jumper wire. But if you don't have the male to female jumper wire, you can adapt that to a breadboard. You should be using electrical tape, but if you don't have electrical tape, you can use regular tape. It's okay. Okay. So do you have any questions for me before we get started? Okay. So I'm going to screen share real quick and then we'll go to the camera. So make sure that you have all the device you need. You're going to likely need some scissors. So what I did was I cut out or you can just have the box. So if your box doesn't have a seam in the middle, you should cut the seam in the middle, so that way you can put in your sensor. And I feel like the sensor needs to be close to where the person would be or your hand would be. So if you wanted to move it a little bit closer to the mouth of the box, that will be okay. My blade was falling off a little bit earlier, so one of the challenge will be just to get everything stick to the blade. So I cut so this is the lid. Let me stop sharing so I can see my camera. Okay. So this is the lid. Okay, you see my box? So what I did was I used the box and then I put the Arduino inside. You can mount the Arduino with the electrical tape, maybe on the side of the box. And then you would likely need to tape the motor onto one of the wall. So you can put it on the left, or if you put it in the back, just make sure that the blade is going to hit this. I feel like my blade is a little flimsy. Then you would take a piece of cardboard and you would tape it onto the blade and just make sure that you reinforce that. I just didn't have time to really tape it. And then on the seam of the box, as I'm using the Amazon box, I put in my sensor. So before you start taping everything together and make a container, it would be better if you just keep it open, and then when everything is working, then you can seal it. Okay. Now, if you're using a box that doesn't have a middle seam, what you can do is you can cut a rectangular or a small hole, and then you just put this through. Okay, kind of like the picture that's showing in the lab. But if you are using the middle seam, I feel that that will probably be the best. Okay. And then I just run the cable to my PC through the edge like that. Okay, so, oh, sorry. Let's angle it like that. Okay. So on the wiring question, I think I have all the pieces. Yeah. So you should have all the, you don't really need a breadboard for this one. If you adapt it to the breadboard, you got to tape the breadboard. So, if you don't want to put it in the box and you just wanted to test the motor, that's okay. But I just wanted to simulate it so you can see that you can put it into a box. Okay, Alex, do you have any question? Or anyone have any question? Okay, so let me share screen again. So when you wire it up, it gives you a list of how you would connect. So your servo is going to go to pin 3 for the data. Okay, that will be the yellow. And then the VCC, the red, it's going to go to the 5-volt. And the black or the brown or the gray, that's going to go to the ground on the Arduino. You can hook everything up directly to the Arduino if you are using male to female jumper wire. Okay. If you're not, then you just have to hook it onto the breadboard, and then you would need to place your breadboard inside the box. Okay. All right. Then on your ultrasonic sensor, we are going to use trigger as for digital pin 6, and then the echo is going to be digital pin 5 5 volt for VCC. Remember that this one has 4 pin, and then the ground is to the ground on the Arduino. And you would have 2 ground adjacent to each other. Okay, so it will be like that. So your question to me should be, well, how are we going to be able to adapt 5 and 5 together? And then you would have to consider, because if you're, then you have to bridge it. Either you bridge it with the cable, or you would then need to bridge it with, let me double check now. You would then need to bridge it with your breadboard. Okay. So then you need to extend your blade. When I did this the first time, I actually used the other blade, the 2-sided blade, and it worked okay because I felt like the single blade, even when you tape it, you have to really reinforce it, otherwise it's gonna fall off. So if we were to do this realistically, this would be we would then need to 3D print this. Okay. You would then need to use Tinkercad, draw it, and then 3D print it. You don't have to 3D print the whole blade if you draw like a little insert. So I think if it fits, and you can maybe like put glue, okay. But right now we're just testing it with cardboard. So you can just cut a piece of cardboard, like maybe 2 inches by 1/2 of an inch. Okay. And it's okay if it's a little flimsy. It's, just to test. And if you're interested in the mechanics of it, you can try to work on it just to make sure that. So I think in this picture, they're using a foam type of piece that goes on top of the blade. Okay. But you can just use the cardboard piece that you cut off. Now, also, I wanted to let you know that for the mouth, because in a realistic trash can, you would have some kind of hinge. So, if it's for my box, the mouth, it's always wanted to wants to push back. So what you can do is you can also detach this piece and then use tape to tape it back. So that way it doesn't have that grease, which cause it to push back. Or you can just press it down and make sure that it's closed. You can test it that way. Okay. And you don't have to use the battery if you're powering your Arduino with the computer. Now, in this picture, the person that created this project, what he did was he actually cut out a little slot, and he would mount the ultrasonic sensor to it. You can do it that way, or you can just attach it to the seam in the middle of your box if your box has a seam. Now, I also saw students that when they did this project, what they did was when they cut it, a little hole to put the ultrasonic sensor there, it would be better if you have some kind of reinforcement underneath. So that means that you wanted to have something that hold it up. So you might want to put like a piece of cardboard underneath it, like a little shelf for it. Okay. Otherwise, it's gonna always want it to drop because gravity. All right, any question? Okay, so as you put that together, question? Okay, as you put that together, you can follow the picture. Now, the picture here shows that they're using other type of battery, but 9-volt is probably the best option if you have one. If not, you can just use your computer to connect. Okay. So for servo motor, we want to include servo. So we're using that servo library. It's very important that you do that, otherwise it doesn't work. So for Arduino, you can just use the servo.h. And then here what we did was we were creating an object called servo, okay? And then we are going to declare the variable for trigger pin 6. We declare another variable for echo pin 5. We have trigger pin output and echo pin input. So remember that echo is when it's listening. The trigger pin is when it sends out the sound, right? And then it's gonna wait to hear the bounce back. So if you stand in front of the box, or if you put your hand in front of the box, right, it's gonna be able to register that, and that's gonna be the input. Okay. Then when we're using servo, we wanted to attach, and remember last week we did an exercise where we looked at how it would be able to rotate. Then in the void loop, you have a variable called duration and another variable called distance. So in C and C++, the way that you save time in or not have to retype and have redundancy is where you would have a comma after that variable for the next. So here basically it's saying that there are two variable, duration and distance. So we're gonna use digital write command for the trigger pin, and we wanted to send 5-volt to it. It's gonna wait 1 millisecond. Then we are gonna remove the 5-volt. So now it will be 0-volt. So this allow us to measure the pulse input for the echo pin. Okay. Now for the pulses, we want to set up for the duration. So the duration, it's gonna pass echo pin high. And this is when we are going to use some information that would need to be pulled from the internet, okay? So you would need to pull the data sheet for your ultrasonic sensor, and you can search for that, okay? So it tells you here in the comment that distance is going to be half of the duration divided by 29.1. So we got the duration by using the pulse in, and that's going to be echo pin high. So that's going to give it 5-volt again. Then our distance, now we are going to calculate it. So we're going to take the duration divided by 2 and then divide it again by 29.1. Okay. Then for the next part, we would then set up the condition if it's less than 0.5 meter. And if it's more than 0, so we have a range, right? Between 0 and 0.5 meter, then we are going to have the servo rotate. Okay. Then it should wait. Sorry about that. That should be in the next line. It should wait 3 seconds. Then for the next part, which is the L's, otherwise, it would then rotate 160. Okay. So you can change this to how you want the angle of your lid to be, right? Now remember that the servo is not that strong compared to the DC. So what you see is that when you're using it between 0 to 180, you would specify the angle. But then at the same time, right, if it's not pushing your lid, then you would want to move that servo closer to the, to the top a little bit, so that way it would then be able to push it up. Okay. Now, when we wanted to rotate a certain angle, we would do a servo right. Okay. So first it's going to be 50, then it's going to be 160. Okay, any question? Okay, let me get my Arduino. So if you like to do, remember that our lab, we're only going to do one of them, but if you like to do them all, I'm fine with that. Okay. So now what happens if you want to use 2 servo motor? What do you think? You just have to use other pin to be able to adapt the second servo motor. So if it was me, right, if I was to do this realistically to sell the product, I would consider having at least 2 servo motor, like one on each side, and then just connect that, right? And then you would need to program the other one as well. Okay, so you would need to have a second servo as a duplicate, because if you're using one, if it breaks, then you're not going to be able to, it's your device or your trash can is not functional. Okay, so let me see. Any question? I gotta bridge my 5-volt. Okay, so test your trash can. If you don't have a box, you can just take a picture with the circuit. But I like for you to test it. So tomorrow we will not have a live session. If you have questions, you can email me. Make sure that we complete our quizzes and submit anything that you haven't. I will be able to grade it, and so I can post your grade next week for this class. As I mentioned yesterday, you will be receiving an email for your badge from Accredible. And then all you have to do is just to create an account. Actually, it has it set up to your email. You just need to accept it, and then it's going to link it. Okay, so you can print out your batch certificate or keep it as a file, or you can also, it will be linked to social media. Okay, it uses blockchain to store the credential information, so um, that server is safe, and it has, because it has some of your information. It doesn't have your grade, it just have your name, your email address, and the course information. Any question? Okay. Okay, so make sure that we bridge the 5 volt. Let me save my file here. So now you would know how to do the trash can, or simulate one at least, that has the ultrasonic sensor. And if you think about, okay, do we have a choice to do either? Yeah, you can, Jose, you can do the piano or the trash can. I'm just going through the first one first, and then I will get to the next one shortly.
And just completing one of them completes the assignment?
Yes. Yeah, I didn't want you to, you can do all 3 if you like, or 2 out of 3. I just didn't want some students take a little bit longer to get the task completed, and I don't want them to have to spend Independence Day weekend working on this stuff. Okay.
Okay,
So
thank you.
yeah, you're welcome. Yeah, so you can stay on and watch. So that way, if you wanted to attempt the other ones, it's just good practice. But if you don't want to do it, then it's fine. Just one is okay. Okay. So I normally have big projects like this for cyber camp, for like, near the end, after they learn everything. After the 2 weeks, they also have 2 weeks, but it's Monday through Friday with me for like 2-3 hours. And so at the end, they, project like this, they will have a competition, and they will work in team because they're younger, right? Usually, um, we take like 11-year-old and up, but sometime, their parents fill out the form because they wanted to drop them off and have something for them to do. I have gotten students from like third and second grade. So I did elementary school coding virtually this year for second through fourth grade. And then there were some older grade students that were joining in. It was pretty fun. All right. If we wanted to bridge the 5 volt without using the breadboard, would would we connect the 5 volt from the servo and the sensor together? Um, I I don't think that you can try it that way, but the way the Arduino slot is made, it's pretty tight with the one individual jumper. Um, what you can do is you can, I don't know, I think we don't have a cable that comes back to it. Um, yeah, you will probably have to adapt it with the breadboard to be safe. You can try to plug it in all together in one slot, but I think on my Arduino is pretty tight. It won't fit both cable. So, okay. It will be better if you have like the cable that goes from 2 to 1. Okay. Um, However, we don't have that. So you can also make one just use electrical wire. Okay, remember jumper wire is just metal and it has plastic coating just for safety. It's for insulation. Okay, all right. So finish that one if you choose to do that one. I'm gonna go over the next one. I already talked a little bit about this. So I brought out tomato because I want to play with tomato today, I think. And you can use anything conductive. Like I said, if you're using fruits, the one that has high acid content works best. Citrus, tomato, potato. Oh, I lost one. Let me go get another one. Later. Okay. So on this one, let's share screen. If you, whatever you have access to, if you have foil, you need to cut 5 individual pieces, like the size of your finger or half of an inch wide, okay, like a piano key. If you have forks or spoon, that's fine. Soda cans, empty or full soda can will be fine. The challenge with the soda can though is it works best with alligator clip. I had tried with Sprite and Coke can, but if you're using empty can, or you can also use electrical tape to tape your wire on top. Okay, so just keep in mind that if you're using cans or spoons, you got to make sure that the wire is going to go from the Arduino to the individual spoon, and it needs to attach to the spoon somehow. So if you have electrical tape, you can tape them on each spoon. Same thing with the foil, the soda can. The potato and the fruit, however, what you can do is you can, let me switch camera on so I can show you. It just virtual is always a challenge. Okay, so here's the Arduino. Put 5 cable into A0 through A5. Just like the picture show you with the Play-Doh, and Play-Doh works really good. You're just gonna take a cable and you're gonna stab the fruit. Okay, that's one key, and you need to make sure that they don't touch, because otherwise you're gonna hear like multiple sound combined. If you want to hear individual keys, make sure you separate them. And so you would do 1 per key. Okay. And yeah, my jumper wire is a little stiff. Tomato is, now that I feel tomato is a little slippery for this. Okay. Now for the lemon, if you're using lemon or lime, if it's quite large, just make sure that you puncture it so that way the metal is reaching the, it's mostly conductive, but if you can get it to the flesh, it's probably is better. Okay. So, oops, sorry. Let me. See? Like that. Okay, and you can make sure that they're separated. Okay? So A0 through A5. Now like I said, if you're using other material, just make sure that you get the wire to stick onto the material. You can also use paper clip to clip it to foil, or just use paper clip in general. That will work too. Let me switch cameras so I can put my camera down. Okay, so let's talk about the steps. Okay, we already talked about what's conductive, what's an insulator yesterday. You need 6 keys, okay? Then you need to download the Hairless Midi, okay? And if you're taking my Raspberry Pi class, I will show you how you can make synth using Raspberry Pi. I did a little bit of this for the CTE day using, I don't know if you've seen it, Sonic Pi. Uh, really cool. Like you can make beats and sound and stuff like that. Everybody likes music. So, okay. So make when you visit this website, okay, make sure that you download the version for your computer. If you're using Windows, okay, if you're using Mac OS, or if you're using Linux like Chrome, we can download this. Okay. Um, Once you download it, you would need to unzip. So 1 second, let me get to my folder. Okay, so I downloaded it on the 27th of 3 days ago, and it would come in like this. It's a zip file or a compressed folder, okay? And then you would right click it, and if you have 7-zip, you can choose extract file, or if you don't have that, you should be able to extract all. Now, if you don't move it, it will be in your downloads folder. It would be better if you want to continue to use this is to put it in a folder or a directory where you can find, okay? So when I extracted it, it would have a folder also with the same name. And if you look inside it, you would see that there are packages that was written for Arduino MIDI. And it comes with the README file. And if you visit the creator GitHub, you can also find the README there. Here it talks about what Hairless Bridge is and how the libraries were created for it. And when you're using it with the Arduino, okay, um, this is how you would write the um, the MIDI begin. So it gives you an example of how to use it. So when you're working with these type of packages, it's best that you take a look at the README, and then some of them they actually put tutorial video for you to watch so that way you know how to use it. Um, okay, and so on. All right. So after that, after we download and extract it, okay, you would be able to see an executable file. It's called Hairless Midi Serial Executable. Okay, so when you open it, okay, see how this says application on mine? That's the one. Okay, it's gonna look like this. So what it's gonna do is it's gonna use a software, which is what we download, okay? and it's gonna take a look at the signal, the electrical signal that it's receiving from the serial port. Why is it a serial port? It's coming from the USB, which is connected to your Arduino. Okay, and since it's sound, it's gonna be analog. Okay, then this is the application, and that's all it is. Now, after you finish all the steps, you would need to run this application in order and then turn on the volume on your computer. So I wrote down all the steps for you there. Okay. All right. Any question? Next step, we are going to also download Python 2.7. Okay. As I mentioned yesterday, that Python 2.7 is no longer supported by the community, but it's still being used. That means that there will not be any version after this one, right? It stops at 2.7.18. And so the community has transitioned completely to Python 3. So if you want newer version, you will need to use Python 3, and they are slightly different. Mostly the same, but some are different. Now, the library, if it's written in Python 2.7 or Python 2, likely that it will work with Python 3 unless they have specific format that was used in 3 that doesn't exist in 2.7. Then that would be that you would require the Python 3 to run that. Okay, so in this one, it's safe to run 2.7. If you have Mac OS, if you're using Apple system, okay, or Linux systems, likely that you already have 2.x installed. Okay, if you updated your OSs recently, it comes equipped with Python, Mac OS X. Okay, um, yeah, so when I teach Python for networking and other classes, um, many of the students, they use other system than PC, so I have to write concurrent steps so that way they can get the packages. But in general, when you install packages, it's basically pip install across anyway. So when you look at this page, if you're using a Mac OS, you are going to click this one. Okay. If you're using Windows, like Windows 10, okay, you are going to use this one, the MSI installer. Okay. And if you're using an older Windows operating system, like let's say Windows 7 32-bit, then you will click this one. Okay. So once you download it, you can go through the wizard to complete the installation. Let me see, I think I did download it. Okay. All right. So I had downloaded this, right? And then you just open this up. Now, if you already installed it, it's going to give you this screen. It says that you already have it. Do you want to fix it? Or do you want to remove it? Change it, right? But if you have never installed Python 2.7, you would then just click next and use the default. Now, keep in mind that on Python installation, sometime it would give you the option to link it to your home path. So if you check that option, you don't have to set up environment variable on your system. So what does that mean? That means that when you run a certain application, like for Python, right, it will be able to tie that to your system directory, your root directory. Okay, so now as you go through the installation, it would tell you that it would put it in, like for example, for Windows, it would say C drive, right, Python 2.7, and that's where it's going to be. Now, Python is, you can use the virtual environment to program a lot of the things, and it's not going to be able to impact, you know, if you start messing up, it won't be able to impact it, and you can use command line for that. However, in my case, I have Python 3.9 and 2.7 installed. Okay. Ideally, yes, you know, you should keep one or the other, but in some cases we might need both. What happens is the first one that I installed was the 3.9, and so it's gonna link. I had selected to be linked to my home path by default. So if I wanted to install any packages for the Python 2.7, I would then need to make sure that it's tied to its directory. Okay. Any question? All right. So once you go through and install the Python, let me pull up my idle here. Okay. I want to show you this. All right. So once I finish, I'm not going to finish that. So, okay. Once I finish, what I can do is I can then open it up. It tells you in the step that, you know, you can check for the Python version. This is a dash dash, okay? And you can do the same thing on Windows PC or Linux terminal, okay? So the command line for Mac OS is called the terminal, and you can find that in the application. Okay. So after you install, you would keep everything in default setting. Okay. And then you can visit Pygame to download. Now you notice that these, if you're familiar with Linux, you know that this is a TarGZ. It's a Linux package. Okay. So it tells you how to install here. There's no graphical user interface that you can install. So look at this information carefully. Okay. So Pygame is a package, and if you wanted to know about it, you click about. And it's a package is different than a Python module in that a package contains multiple modules, and each of the module can be used for things in your game that you're going to write. Okay. And it would have different functionality, and they would always add new things to it. So Pygame is often used for making games. Okay. And I like to use this with Raspberry Pi. Okay, but there are other tools beside Pygame. Okay, like you can use Kiwi. There's so many, you know, OpenGL, and there are a lot of different libraries that you can incorporate for 2D and 3D games. But on the simplest level, Pygame is a good package to use. And see, it uses GPL license, so it's free. Okay, and it works with C and assembly functions. Okay, so we learned a little bit about Pygame. Now let's go back to the last page that we looked at. It tells you that these are the packages, and on the Mac OS, in order to install the packages, you need to use a tool called Wheel. Okay, so you need to do a pip install, and when you're using pip alone like this in the shell of Python, what that is it's gonna usually default to Python 2.7. If you wanted to install the packages for Python 3, you need to say pip 3. Okay. Okay. And then for the Windows, if you wanted to do the easier version instead of doing the pip install, you can get the zip file. So I'm going to download that to show you. And then if you're using Chromebook, you can use this, but you would then need to open up terminal or be able to unzip it. So targz is a Linux format of compressed file, like equivalent to the zip. Okay, so you need to decompress it or extract it. You can do that with the terminal or through the graphical user interface. Okay. Oh, sorry, this I show you, this is the source code. Let me get to, okay, for the Pygame, let's look at the Win32. Let's do the 1.9. Oh, yeah. Let's open up idle real quick. 1 second. Oh, I meant to show you this right now. Okay, so when you install Python, there's an IDE which contains a text editor, right, and an interpreter. It has a shell, right, and then so that way it can execute your commands and your script, right? Python, we call it script, we don't call it code. So now I have 2 versions installed. So when I call up idle, you notice that I have the 3.9, and then there's a default called the Python GUI, which is going to be 2.7. Okay, how do you know which version you're using? It tells you at the top. Okay, so when you open up idle like this, if you have multiple version of Python installed, look at the specifics. So if I'm using idle for Python 3, I need to click this. If I'm using Python 2.7, I simply use the old GUI. This is the app. Okay. And if you only have one version installed, when you call up idle application, it will just default to the one that you have. Okay. So when you look at it, the first thing that you see, this is a shell. Okay. So in the shell, I can do something like this. 2 plus 2 is going to give me 4. Okay. So the computer itself is a calculator. So you can execute arithmetic, right? And be able, it's going to output. So something like this would be useful when you're doing like an import. You can do line by line in shell. So let's say I don't want to write a whole Python script with many lines. I can run each line in shell like this. Okay. So this is what called a Python shell. Now, if I want to write a file like a, like a program, then I'm going to go ahead and be able to, you can open a file and then you can have a new. Where's the editor on this? Okay, so but this is all we need actually. Okay, you can restart your shell, you can edit your shell. You can configure it. So in the instructions, when I wrote that instruction, it was it tells you that you need to download this, right? So 1 second, let me test something real quick. Okay. All right. So I'm running Windows system, so I wanted to show you how you can do this in command line. Okay. And you can do the same thing in Linux and Apple system as well. So instead of using command prompt, you can also use terminal in equivalent for Linux. Okay. So how do I open up command prompt? I type in CMD for command prompt. And what we would use is we are going to use a command called pip install Pygame. Okay. Just like what they instructed in the documentation. Okay. So now if you wanted to, sorry, let me go back to this right here. If you wanted to really understand how to work with the package, you can go to get started. Okay. And it tells you right here, if you're using, you can also use Python 3. Okay. So you can do Python 3 m pip install. It walks you through the steps. Okay. So, and it also shows you how you can use it as an example. Okay. So here it says the best way to install Pygame is to use pip tool, which is what Python uses to install packages. It comes with your Python recent version. You can use the user flag to tell the install into the home directory rather than globally. Okay. So Pygame also, it works with the later version as well, right? They updated for for 3.7.7. However, your library is written in 2.7, which is a different version. Okay. So what I did was I opened up command prompt and you can do a pip install Pygame. Okay. So when you do this, if you want a specific version, then you can type in the version number. But if you want the latest version, this is what you do. You just do a pip install. Okay. And if you want it for Python 3, then you should say Python 3, like how they instructed it. M pip install. And you can point it. This is for the specific user, your current user, or you can have the specific on how you want to install. Okay. So when you issue that, what happens is I already have it installed. It's going to go through for like a minute and it's going to put it in. Now, if you're on Windows PC, if you receive this little yellow message, that's okay. Because what it's saying is that the pip version that you're using is outdated, right? They update it all the time. Okay. So if you want to fix it, what you can do is you can follow the instruction right here to upgrade the pip. Okay. Any question? So this is how you install Pygame. Now, the greatest thing about using command line to do this stuff is it's going to go out and it's going to find it for you. You don't have to go and download it and extract it and pull it up. And for that reason, I love Linux, right? Windows is a little clunky in that area, except for, for Python stuff it pulls it for you. Okay. Question. So do a pip install. And then if you're using Mac OS, when you try to do pip install Pygame, if it tells you it's missing wheels, it will give you a message. It will ask for you to install wheel and so on. All right. Then once you have your Pygame, okay, let me see if it linked it globally. I'm curious. Yep. So if you don't install it, so when you download and install Pygame, right, it's going to default to whatever that was linked in the directory. So it cannot find a module because it's looking inside the Python 2.7. Okay. Now, if the way that you can fix this is you can set up your environment variable in Windows, which is through control panel, and then or if you have Python 3 like me, then just use Python 3. Okay, system, go to system, and then go to advanced settings, and then go to environment variables, and then here is where you would set up your system variable. You would then click let me check. Go to path, edit, and then you can add. Okay. And I see some of you that already took me for CIS30B. You already know we've done this quite a few times for our classes. So, okay. Any question? Now, you can also run Python in command line. Do you know that? Okay. So here I'll show you how. This is my Windows command line. Let me. And this is my default path when I open up command line. If you once you install Python, you can call up Python. Okay. And when I do that, what happens is it's going to default to the one that I installed that's linked to my to the system path. So here is where this now is in shell. So you can use shell directly like this, or you can open up idle, which is, you know, its own tool. Okay. And then you can also have import. Now, let me see where we at now. Okay. So after you import Pygame, you would then hook up your jumper wires to the Arduino, then to your conductive material. Then you are going to open up Arduino IDE. You're going to make a new sketch. Okay. and you can then need to plug in your Arduino and set up your tools for your port. Okay. The next part is you need to bring in the ADC Touch Sensor. So what that does is instead of using the capacitive touch sensor, you are actually using a software, right? The module called ADC Touch Sensor, and be able to make your buttons, each of the fruit or whatever you're using, become capacitive sensor. Okay, so when you touch it, it's supposed to sound. So in the next step, what you need to do is go to Tools, Manage Library. Okay, here's the search bar. Okay, so when you type in ADC Touch, okay, the instructions tell us to make sure that you get the touch sensor, and you're going to install that. So once you found the touch sensor, you are going to click install. Okay, so what that does is it's going to bring in this library to your IDE for Arduino. Okay, and it tells you that this is using without additional hardware. For the library, uses internal wiring microcontroller to measure the capacitance as much as described. Okay, and you can also find the GitHub information and read about it. Okay, so after that, you're going to close the library manager, open up your new sketch, and then you are going to write this in. Okay. Oh, I'm sorry. You are going to open up a new sketch, and then you're going to edit the piano file. So when you bring in the sensor, right, it's going to give you a file, and we are going to modify this file, and we are going to comment out some of the area. Okay. So file, example. Right here. So after you install your ADT Touch Sensor, you will see a list of files, and you need to navigate to capacitive piano. Okay, like that. Okay. So it gives you this file, and then what we want to do is we want to edit some of the area we need to comment out. Okay. Otherwise, you are going to run into error. Okay. So we need to make sure that we put in the // so that way we would then comment out some of the line. Okay. Any question? Okay, so look for those lines. And you need to comment those out. I haven't revisited this. They also could possibly also rewrite this like that.
Presser one.
Yes.
I don't know if you saw the chat, but
Okay.
pretty much I was asking, do you actually take do you teach a Python class, or like
Yes, I
does
do.
okay? So I'm asking because like, do I need any like prior knowledge to anything
No.
before taking that? Oh, great. Okay. Do you teach it over the semesters, or do you do summer? Or
Yeah, I just started one. Some of the students in this class are also in that class. It's called CIS30A.
okay,
And
CIS30A.
yeah, we are not offering in the fall, but likely it will be offered in the winter. It's a
Mm-hmm.
6-week course. And
Okay.
I have a whole certificate for Python programming in networking, cybersecurity, IoT, and advanced Python with data science.
Oh, that's great. Okay.
Yeah, so if you're interested, CIS30A it has a CIS1A prereq, but there's a waiver that you can use. We are trying to remove the prerequisite, but it does take a little bit of time. So if you
Okay.
haven't taken CIS1A, you have to just email me and I will
Okay.
show you how to
Yeah.
do that. Okay.
Okay. Thank you. I'm only asking because I actually have an interest in like some robotic stuff and everything, and I know a lot of people are using like Python and whatnot, so
Yeah.
that's why.
Yeah. Python is commonly used in a lot of different areas. It's a preferred language because it's in general there's so many resources for it. Okay. Sorry. I don't Yeah, I just saw your message right now because when I share screen it doesn't show up
Yeah, I
my
figured. I think
message.
that's what. Yeah. No, I know.
Everybody is like that on Zoom. And if you click it, it takes forever just to load the chat when you're sharing screen. And I'm on a 16 gig RAM PC, and I thought I have decent bandwidth, but then again, I almost picked up another one that has 32 gig of RAM the other day, and I missed it. I bought it, and then I didn't pick it up in time because it's in Orange County, and they had put it back on shelf, and now it's sold out. So mad. Anyway, all right. So find a line, comment out your line, and the way that you comment out, right, for Python, or yeah, for Python, you would use this. Actually, this is for C. I'm sorry. For C, you would use // and then for Python comment, you would use the hashtag, but we're not doing that yet. Okay, so this is in C. Okay, so any question with what we had to do? Then you're gonna upload. Okay. Then you're gonna go back to the Hairless Midi application that you previously installed, right? You already opened it. Okay, so it's gonna look like this. It looks like like it has like a little black strike icon. So open it back up. Okay, so it's like this. And in the application for the serial port, I don't have my Arduino connected yet, but you would then need to select the COM port that for your Arduino. You would find it when you click the drop down arrow. Okay. And then for the MIDI out, which is this one, after you put your COM, for the MIDI out, you would then tell it that you are going to use the Microsoft Synth. So that way your computer would be able to recognize it. Or if you see some kind of synthesizer there that's listed, that's the option that you would select. Okay. So the software, what it would do is it's going to receive the signal from the serial communication port and it's going to convert it to a synthesize or a synth, which is that's going to be like some kind of sound that would be interpreted by your OS, and it's going to output it to your speaker. Okay. So at the low level of the machine, what that does is it's gonna have an input from the Arduino, which receives the input when you touch, your fruit or your conductive key, and then it's going to transfer that, and when it outputs, it's going to convert that to an analog signal that's going to be out. It's going to use a software tool to convert it to a synthesizer sound as an analog signal. Okay. And then you are going to open up your terminal, your command prompt. You are going to, now if you're using Mac OS, sorry, I wrote this in the intention that all the little kids were using PC at our campus, but you need to go into the directory where your Python 2.7 exists. And for if you're using Windows system, it's default in C Python 27, and it's under scripts. This is where you should also install Pygame. If you install Pygame earlier and if you import, it's giving you an error in red, it's because it's not linked to the proper directory. You would need to do a pip install PySerial. What this is a library for serial signal. Okay. And I borrowed this project from the GitHub here. I have to massage it quite a bit. Like when I went through it, I really had to rewrote some of the things because there's some resources that are missing. So what you see is, the fixed version of it. Okay. So after you install the PySerial, you're gonna go to idle, or you can even, if you don't have idle installed, open up Notepad, text editor, any kind of editor works. Python is super flexible. Any programming language, you can write it in any text editor. Okay, as long as you save it as a file format that it understands. Okay. So after we write this file, we would save it as a .py for Python. Okay. Any question? Okay. So let's kind of get into this a little bit. I know that some of you never took Python programming before. Some of you are in it now. Some of you kind of know because you did some tutorial, but I'm just going to give you a quick rundown for this. So the serial library that you just install, you're going to import it in. Okay. So installing the library doesn't mean that it's ready for use. It's just there, right? If you're using it, you're going to bring it in, okay, by doing an import. So this is equivalent to C++ include, okay? So think about like we've been using include servo.h. It's like saying in the C program, it will say include serial.h, very much like that. But now this is a Python file because the library that's written for the hairless is in Python. We gotta make sure it talk, okay? So we're gonna import time. We're going to import Pygame, which we installed, and we are going to import Pygame.midi. Okay. Now, on the next two lines, it says from sys import argv version info. So when you do an import, you're bringing in the whole thing, right? You're bringing in the whole file. But when you're doing it from an import like this in Python, what that does is it's bringing in the specifics from that file. Okay. So, and sys already exists, you didn't have to install it because this is part of the Python packages that you installed earlier. That's for system. Okay. And then we import time. And this is, sorry, this should be on the next line. I see, oops, never mind. It is on there. So from time, we are going to put in sleep. And sleep is the same across many different languages. It's the same in Ruby. It's the same in Python. It's the same. It's just wait. Okay. So here we have a byte to int. It's a conversion for the data type. So we're going to convert byte data type to integer. Okay. And then this is going to be for specific version. Here is where, similar to the pitches.h that we worked on, you have to set the values and the note for your key, right? Like think about the piano note or the piano key when you strike a note, right? We wanted to make sure that we have the duration value and the key information, okay? And then, so here is your width and height. And what this is going to do is it's going to show you black and white key when you play this, okay? So black and white, that's going to be equivalent. And remember that this is analog and pulse modulation uses value. So 255, 255, that's the highest, and 0 is off. Okay, so your key width is going to be width divided by length. And we're going to pass the note value. This is just the formula for the key width. Okay. So for the next part, this is going to set up the command, and that command is going to talk to the application Hairless. Whatever the port value that you use for your Arduino, you need to put that here. If it's COM5, put COM5. If it's COM1, put COM1. Okay. And Python is very forgiving in that you can keep it all on the same sentence like this, and or the line, I should say sentence. Line like this, it would be fine. Okay. If it tells you an error, then you need to just make sure that you would. So this is a statement that's going to follow this, and it's going to print. So it's saying that for port, that's going to be COM8 with the condition that it's going to be with this argument, otherwise argument 1. Okay. And then we want to print it. This is where we set the baud, and you notice that this is a lot higher than the 9600 we've been using in the serial monitor. So this is going to be for our serial. And it's going to read the line from the serial. This is an object, and it's pulling, right, the method from the library, serial library that you download and imported. Okay. So the next part, this is just going to draw out your key so you can see your key, and then you are going to have it print. So you are going to get a little bit of the UI, the user interface, when after you finish this. Okay. Then it's going to show your MIDI setup. It's going to do a MIDI out, so your MIDI output, and this your your initialization here comes from the Pygame. So whenever you're using a module for Python, you would put the module name and then the method or the property that it's using. Okay. And it's going to show piano on screen. So all this extra stuff right here, it's the graphical user interface. And you are writing it in Python here. Okay. So for those of you who are taking my Python class now, this is what you're going to see in the TK Enter module that's we're going to go over near the end. Okay. This is the for loop, and it needs to iterate through it to draw each of the key. Okay. This is a function that, so when you strike a note, it's gonna be able to, and it needs to iterate to it. So the note value, it's gonna index, it's gonna, for each of the note, it's gonna bring down the note information. Because earlier, we have an array or a list of your notes. So it needs to index through each one of them. Okay. And Python called that a list, not an array. So it's the same as an array. Okay. Let's see. All right. So for the next part, this is a try. This is just going to be for, you can nest the statement like this. This is kind of like equivalent to catch and try in Java or C. We often use it to, catch errors, but you can have it to really implement specific conditions. And this is just to handle certain type of event that could occur. Okay, so programmer, they would then predict like what could something be happening. So without going in a lot of this area, because it's just going to get complex, but you would see that they implemented, with the data and how the command is used from your system to your actual device. Okay. And so the interface that you have is the button or the key that you connected, but yet at the same time, it also needs to show that on the software when it runs. Okay. And so the try part was for exception handling, possible things that needs to really look at the potential event that could occur for your application. So when you use a try statement in Python, if you wanted to handle exception, you would then follow it with an except. There are several other ways, and my students cover that next week, in week 3. Okay, so in case that it runs into issues or error, it's gonna say disconnected, and it's gonna close that out. So we have a close method here, close out the MIDI, so it terminates that signal, and it's gonna quit Pygame. Okay. All right. So after you have that file written, save it as a touchpiano.py. Okay. Now, if you're using command line, you can run the file, or if you're using an IDE, you can just click run at the top. So in idle, you just click run, or you can press F5. Okay. And you should see it. If everything works and you follow all those steps, you should see your piano key, and then you can start playing with your fruit. or your key, and it should sound and it should show your black and white key. Okay. Any question with this one? So this one is a little bit more complex that we have to deal with, you know, Python and so on. I was not able to find a library or, you know, a project that uses C only. I looked, I searched, but maybe it's been like about over a year or two. So there might be new people adding new projects on there. But this gives you an opportunity to kind of see how Python is if you haven't learned it. Okay. Any question? Okay. So check that one out. And then on this one, you can still use the same, you know, fruit or paper clips or spoon or things that you have to the wire. This one is a little harder in that you have to follow the schematic. Okay. And the buzzer that you have, it's, you know, it uses the pitches.h on this one. Okay. So anybody tried the third one yet? No. Or the second successful? Okay. So we talked a lot about how, you know, everything should be connected and stuff for the last couple of days. So I want to touch on the code a little bit, and then we'll finish up and we will wrap up the session. So you are going to use pitches.h. You saw how this was done when we start using the buzzer last time. Okay. You are going to use capacitive sensor.h. Okay. So you are going to import that in. You are going to use speaker 11, and notice that you're bringing in the library so you don't have to declare or customize your variable like what you've done in some of the other exercise. Okay. And all of these right here came from this library. Okay. And all you have to do is to set it where how you connect your pin. So your send pin go first in the argument, and then your receive pin follows. So your send pin is going to be 2, and the receive is going to be 3, 4, 5, 6, 7, 8, 9, and 10. And you want it sequential, so in case you need to troubleshoot, you would then go to that wire connection and see why it's not working. Okay. So this is going to be declared at the top after we include the library. In the void setup, we would turn off auto calibration, and because otherwise it takes a while. Okay. You can also turn off, you don't need you should also turn on your serial monitor, so you would begin at 9600 baud so you can see it in serial monitor. And then we would have the time for the timer. Here is where you would set sensitivity to your key. So each of the key, this is, you know, like 3, 4, 5, 6, 7, 8, 9, that's going to be the sensitivity. And we're using the capacitive sensor from the library. Okay. And then we would show, this part is just to show on serial monitor. Okay. So first it's going to do the check on the time. Sorry about the typo. And then it's, you know, as you touch them, it's going to then show the output for each. Okay. And let's see. So here is where it would produce your tone, and you have to put in the if. So in my opinion, this can be done a little cleaner using case switch statement, but you can nest a bunch of ifs in here like this for 3, 4, 5, 6, 7, and 8 key. Okay. So if I need to revise this program, I would consider doing case switch like what you've seen previously. So you can do one case per key and then break from it. So it is actually a little better to handle that. Okay. Because when you nest all of this in, what happened is you reduce the efficiency of your system. Okay. All right. Then, so that's going to be for your tone. Okay. Here's your frequency. Okay. Then if you don't touch it, you got to tell it what happens, right? Because Arduino, the microcontroller, it is a computing system. You really have to instruct it what happens when there's nothing and what happens there if there's an event. So when you already stated that if there's an event, this is what happens, it's going to output some kind of tone. But if there's not something that's touched, what's going to happen? Because technically it's still going to be, you know, on that paper and it's clipped in, and or when you touch it, then it's going to sound. When you don't touch it, then it's going to have a condition for that. Okay, so we would say no tone speaker. Okay, and then pause. Okay, so between the Python one and this one, the hairless one and this one, you can see that on the microcontroller side, right, you also need to set the specific with the ifs. On the Python one, that program spends a lot of time really give you the graphical user interface so you can actually see the key that you press. And we would replace that with the serial monitor on this one. Okay. It's not going to be pretty like what you see with Python, but it's good enough so that way we can see what's happening. Okay. It both uses library, and then you also have the key set up. Okay, so you can see the difference between using something that's very software oriented to compare to something that's very hardware oriented. That will be those exercises. So you just have to do one. Take a picture of it, turn it in for the lab, and that will be it. Okay, any question? Okay, so no live class tomorrow. I hope you really enjoy your long weekend. I will be thinking of you in Portland, Oregon. I want to thank you for a good non-credit session. This is the first time that we offer Arduino for the beginners, and this is the first time that I teach it as well. And I look forward to most of you in the next course, which is Raspberry Pi. You will have other students that will join as they don't take Arduino. And so for the Raspberry Pi class, just heads up, have a keyboard mouse ready. If you're using laptop, make sure that you have your VNC ready. I put a link on the class information. Make sure that you read the documentation there and set up your VNC. Okay, but easiest is monitor, mouse, and keyboard. Okay, and I will walk you through how to best set up your Raspbian and get into working with GPIO with electronics and also programming games and music and things within Raspberry Pi. Okay. All right. Any questions before we depart? I will be available until 4 p.m. in case you have questions on your project or are concerned about things. Okay. So if we have any outstanding or missing work, make sure that you get them to me by Monday. Okay. The dean has sent me an email. She wanted me to send up the grade for this class. It's either pass or no pass, um, you know, by next week. So I wanted to make sure, and then I will set up your batches. Okay. All right. Have a good Independence Day. If you finish everything, our already knows. Type your name into the chat. I will see you in the next class, maybe. If not, I hope you can take my classes. I'm teaching 5 classes in the fall, so including advanced Python and Python for cybersecurity, which is ethical hacking with Python, and some networking in the IT classes. Take care, everyone. Have a good weekend. Have fun. You're welcome. Bye.